Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week. And I must be honest with you, I'm not exactly following doctor's orders here because the time, if I look at my cell phone here, is 1:45 in the morning, and I'm supposed to be making sure that I get all sorts of rest. But PowerPoint has been giving me all sorts of challenges again tonight, and so I'm trying to record the audio without my picture in the corner and see if that works any better. So we shall see. But anyways, the reason I'm doing this is that the rumors are already flying about a major East Coast snowstorm, not this week, but next week. And so I try to do what I always try to do in these types of situations is reel everybody back in and talk about the chances of something like this happening, which are not zero, but I would say at this point it is not likely. Could that change over the course of the next 7 to 8 days? Sure, it could. But there are already people talking like this is a done deal, and I just want to make sure that you know that it is not by any stretch of the imagination. Okay, so what I want to do first here is take a look at the ensemble mean upper level flow forecast for Sunday, February 4th. And these green colors that you see down here, and I'm going to see if I can't pick a something fat enough here so you can actually see this. All of these green colors that you see in here and back in here, these are what we call below normal heights. And when you see heights this far below normal at these really far southern latitudes, that's telling you that the jet stream, the southern branch of the jet stream, is incredibly strong. There's a lot of energy in that jet stream, and there's a lot of potential for storm development very, very far south. And if you're a snow lover, you know that a lot of our important storms originate in the Gulf Coast or in the Gulf Coast states and then move up along the eastern seaboard. So we have this one upper level low sitting in here, and then we have a second upper level low up here over the eastern tip of Maine, okay? And this is important, the placement of this, because I have talked about this in the past, that the best pattern for a major snowstorm in North Carolina is for a split flow and for the two streams to be out of phase. And by out of phase, I mean the trough axes are not lined up, or the trough axes, I guess I should say. So up here, we have a trough axis here. Let me see if I can figure out a way to erase everything here. There's got to be a way to do that. Yes, there we go. Okay, so let me go back here and pick this one here. So the trough axis with this upper level low is here. Then we've got the southern branch system here. And the only problem at this particular point in time is that this thing is just maybe a little bit too far south and west. The circulation around this thing is bringing dry, cold air all the way down into northeastern North Carolina. And we want to come under the influence of this southern branch system if we're going to get enough moisture up here to do anything with regard to rain, snow, or anything else. So this thing needs to get out of the way just a little bit so that this thing can maintain its identity and move eastward and allow this storm to develop and then perhaps head up the southeast coast. Now, let's move on ahead 24 hours. Well, the ensemble mean is indicating that this upper level low is going nowhere, okay? And so what that's going to do then is force the southern branch system to get absorbed in the flow around this upper level low. And so we end up with what we call a full latitude trough, which is not what we want. And all that would happen there is that this storm would head out to sea and cold air would pour in behind it and nothing would happen, okay? But this is an ensemble mean, okay, of 51 different members, and they're not all showing the same thing. So in light of that fact, let's take a look at a detailed breakdown as to what all of the ensemble members are actually saying. Okay, so this is the ensemble breakdown for RDU, and we're going to label a couple of different columns here. First of all, the ensemble mean, the average of all 51 ensemble members, is 1 inch. However, that can be misleading because you can have a series or just a few ensemble members that are going for very, very high amounts, and that skews the average upward, where if you actually look at how all the ensemble members break down, most of them are not up at 1 inch or higher. Most of them are lower than that, okay? So the average can be misleading. Now we're going to take a look at a couple of different columns here. One is going to be the snow threshold, and the other one is going to be the percentile. And basically, if I was looking at the 50th percentile and that was 1 inch, that would mean that 50% of the ensemble members are above an inch and 50% of the ensemble members are below an inch. So that's sort of the way that works. So for 0 inches of snow, that goes all the way from the minimum up to the 60th percentile. Okay, so 60% of the ensemble members have absolutely nothing with this event next week. Now, if we go to measurable snow, which is defined as 0.1 inches, then that's the 62nd percentile. And you may be asking yourself, well, what happened to the 61st? Well, it's actually, the 61st is actually an amount between 0 and 0.1, but since it wasn't measurable, I didn't think it was important to put it in the table here. So the 62nd percentile is 0.1 inches, which means that 62% of the ensemble members are not measurable and 38% are. If we move the threshold up to 1 inch, then it jumps to the 82nd percentile, which means that only 18% of the ensemble members are at 1 inch or higher. If we go to 2 inches, it's the 84th percentile, 3 inches the 88th, and 4 inches the 90th. So 10% of the ensemble members have 4 inches or more of snow, and 90% have less than 4 inches, and again, 60% have nothing. If we move the threshold up to 5 inches, it's 92nd percentile. For 6 inches, 95th, 7 inches, 96th, 8 inches, 98th, 9 inches, 99th, and 10 inches, which is the maximum amount put out by any ensemble member, is at the 100th percentile. So it's important to recognize here that the majority of ensemble members are going for nothing. However, it is not exactly a whopping majority. Like, if I'm remembering correctly, I think in Congress you need 2/3 to veto a bill or something like that. This would not be enough, okay? So 40% or 38% of the ensemble members have measurable snow, 18% have an inch or more, and then it goes up from there. So it's not an impossible thing for this to happen next week. It's just that the overall odds right now are skewed against it. So the really critical thing to watch for here is going to be whether or not these two streams, the northern branch of the jet stream and the southern branch of the jet stream, can maintain their separate identities long enough so that the northern branch can distribute the cold air and the southern branch can contribute the moisture, so that we end up with an interesting situation next week. So at this point, the odds are against it, but not by a unanimous margin by any stretch, or even close to unanimous. And so we've got something to keep an eye on here. And, who knows? This may end up being our best chance. And if we don't pull this one off, then, it's time's a wasting here as we get deeper and deeper into the month of February. So that is bonus weather video number 1 for this week. I hope you found that interesting. Obviously, I will be keeping a close watch on this over the coming days, and we'll see how all of this plays out. But we've got 8 or 9 days to watch it, and so a lot can happen, and we've got plenty of time. All right, folks, you all take care, and we will talk to you later today with the first daily weather update of the week. Take care.